That is that at least one of them. Finite test. Finiteness and definiteness. There is a procedure you define. Same thing. You want to prepare a biryani. So we are expected to have how many number of steps are there? That steps must be for somewhere else we will be finished. 1, 2, 3, 4, 5, 6. Till how many steps? We can able to say this is a procedure will have 100 steps. This procedure 90 steps. This procedure will have 1,000 steps. That number what we have defined now, that is finite amount of steps. And every solution, it's your own way. You think you are fine, but that point that must be end at finite amount of time with a finite amount of steps. We cannot say how when it will be procedure will be completed. And you are defined that 10 steps or 100 steps, 30 steps. You can able to say my procedure is the only procedure. But also you can able to say my procedure is so and so, and we finish it is 1 hour only. That the making of biryani will take only 100 minutes, 1 hour. As somebody is 40 minutes only, we follow this procedure, it will be finished in 40 minutes. If we follow this, it will be finished in only 30 minutes. Like see, that is finite. The number should be definable, finite amount of time or finite number of steps. Whereas definiteness as it is. Definiteness, anyone? Characteristics of an algorithm we must follow before announcing that this is a solution for the problem. This characteristic says that every statement in your solution, every step in the solution must be definable. Must be definable in the sense meaningful. As we have written now, every statement in your solution must be meaningful. Define that. So what does it mean? X equals to x into 1. But what is the use of that? There is no change in the x value. So that is definite. Definite sense we can able to define, we can able to have some changes in your procedure. Last one is finiteness. Sorry, effectiveness. Every statement of an algorithm, every statement of a solution must be effective, something effective. There is no such an effective. And also that there is no such an effect. As definiteness says that if the statement is x is equals to y by 0. What is x equals to y by 0? If it is statement executed x equals to y by 0, what is the value of x? X value after computing x equals to y by 0. What is the value of x? The statement executed x value y is 2. Y is 2. 2 by 0 रहता है 2 by 0 0 infinite. So here we don't 5 by 0 something by 0 is infinite and x is equals to this infinite will be produced. Then we can say there we will get an error. So there is no in that statement. There is no such a useful of the statement x equals to y by 0. So every statement should be effective. If such a statements are there. So these are the 5 characteristics you have to so that's what I wanted to say here. Problem P is there. For the problem, there exists number of solutions. Solution 1 defined by you, solution 2 defined by you, solution 3 defined by somebody. We follow 3, but ultimately 3 are acceptable because we need a result. If you want to produce a result, 3 will be accepted. It is one is the final solution. We have some criteria. The criteria is that you check the performance. Performance of solution 1, performance of solution 2, performance of solution. Performance can be measured by 2 factors. How much of time the solution will be produced. If you follow your procedure. If you follow your procedure, how much of time the solution will get a final solution. Follow third solution, third procedure, how much of time it will take. So this is called based on the time we decide this will be the best one. 3 are the solutions. Among 3, 1 will be the best because solution time complex. Based on the time complex, one time complex. So not only always time complexity, sometimes it is criteria to that space also. Space occupied. So every statement in algorithm, whatever the variables are used, and every program, it occupies some amount of memory. When integer variable occupies 2 bytes memory, such a way we calculate over the memory space required for the your solution one. How many bytes, how many bits. So solution 2, how many bytes of memory is required. So solution 3, how many bytes. Based on the memory occupancy, space required to follow this algorithm. Space required for second algorithm. Space required for third algorithm. That is the second factor to measure the performance of an algorithm. Space complexity. There are factors, space and time complexity. Space and then there are 3 algorithms exist. Based on these 2 factors, your criteria is the only type. You need to complete very quickly. Anyway, provide a space. What? Space. Minus space is there. Very quickly I need to finish. So sometimes what happened that the preparation of same example, if you want to prepare a biryani, we'll provide everything. So if the ingredients are made also no problem, we'll provide ingredients. My criteria is that prepare that biryani within half an hour. And somebody has a criteria is that no, I have to use less ingredients with less number of ingredients or to prepare biryani. Time is no fact. Then there are number of procedures are there. No? You select a procedure in such a way that whichever procedure will complete them within a short period of time. If the criteria is that the eppalina but biryani kaavali, but other uses with a less amount of cost. Items accordingly. Then what is the criteria? Criteria is that select ingredients we use. They may write a number of items used. Here 10, here 3, here 5. So ingredients 3 the uses the everybody's. But it takes more of 1.5 time. No issue. For me, time is not factor. My factor is that creativity, ingredients uses is there. And somebody else creativity. it says how many ingredients you want, we'll provide it. But only half an hour like possible. So based on that, select a procedure from the existing procedure. And along with these two, usually we discuss these two. One more performance analysis. Amortized analysis also will be there. Amortized analysis. Yes, amortized analysis not there in your syllabus, I think. But just you have to remember that same set is three. Performance of an algorithm can be measured. Usually we say time and space. Not only these two, we have one more thing. Usually we'll have a question again. Amortized analysis also will be used to check the performance of an algorithm. The time space already there. So one more thing new thing is amortized analysis. And so with this, the performance can be measured, the notations are there. That is not your syllabus. We have a topic called recurrence. The next topic is next. Actually, in another after this recent over, divide and conquer technique. Divide and conquer approach. So, there is different algorithms, different procedures exist for the problem statement. So, analysis of writing of algorithm, you can write any of the different ways a solution for the same problem. Right. So, algorithm can be written. If you want to write an algorithm, then must follow some different techniques, different approaches. So, one approach is divide and conquer. And for every problem, it may not be follow same procedure. It may be follow same procedure. Tomato one follow same procedure. Follow same procedure. No, it is not same. Depends on the problem. Depends upon the your requirements. The procedure will be, isn't it? In Lukma just for the no, right? So whether you have a procedure that take it up or to make an EDI. No. So depends on the problem, you have to change your procedure. VI and Bitcoin, thermodynamics procedure Bitcoin. That depends on it, and you are serving as a VI. But what is this a VI? Very problem. Then we algorithm you want to write an algorithm. Yes, I know how to write an algorithm. And while writing, what are the conditions? Make sure that while writing an algorithm, you have a 5 characters. My algorithm have at least 0 or 1 input, and it should be produced at least 1 output. You should have an effectiveness of every statement, and my follow different follow. Right? These are the 5 characters you have to follow while writing algorithm. This follow these 5 conditions. But I'm trying to write the same solution for the problem or problem to problem. Same procedure I followed, sir. Same procedure I followed. So it doesn't affect the solution for the problem set. Based upon the problem, you have to change your style procedure. And this is the one procedure for writing of a solution for algorithm of the problem type. So and so type. Which type of problems this method will be used for? This divide and conquer approach is a one type of approach, one type of algorithm, one type of method for writing of algorithm for category of the problems which are dividable. So solution and problematic. A problem which can be divided into subproblems. Then you follow this. The name itself says that this is a procedure of writing an algorithm of type or category of the problem is divide and conquer. This divide and conquer is that first of all you should know divide. Divide Divided divide means the problem P is there is and write a solution, write an algorithm for the problem. And you have to know that my algorithm should follow some criteria by conditions. Else it is followed. Make sure that this simple problem cannot be solved at a stretch because the problem is very lengthy. And you have thought that the problem is really very lengthy. I am unable to do my alone. So that's what projects in the reference projects, E project minus project included. Usually the project cannot be done by one single person. At least making to do the project will make some groups. And otherwise we have an electronic lab here. EDC lab is there. Some electronic lab will be there. EDC lab there. Lab होता है फर्स्ट ईयर तक EDC सर्किट पैटर्न BTK lab होता है BTK lab experiment single experiment can by a single user. They made some batches, batch of 4 people, batch of 3 people, batch of 1 people, 5 people. Right? See, this is a one batch made it to do this experiment because their experiment they have printed that one student cannot be able to do because there is a very lengthy problem. Lengthy experiment. As all the 4 members get together with it. So what 4 members have shared? The 4 members they have designed a problem statement. Somebody else taking care of the circuit diagram. Somebody will connections as given. Somebody else will note down the results. Right. Such a way the work has been distributed. Then finally we give a result. So this is a result of 20 experiment produced. Same way the project also. The project is just to prepare a library management system. Prepare a library management system. Prepare your attendance management system. So what is your attendance management system? So you prepare one app. In the app, you have to register. Once it is registered, so students of class 20 should be appeared. And I want to take some first over, second over. Based on that, I have to provide an option that what is your subject name and what which hour, and then the list out drop down list, student list should be there. Against the student list, for checkbox is there. If it is present, take it. Otherwise, just it is empty. Such a project is you want to develop, but everything is single user cannot be possible. Because of that reason, we made a group with 4 members. The 4 members have distributed the work is that. So first you do, first person will be collecting the data, and next person you are designing web page, right? And some person will write on the background. Somebody else will take care of the database. Such a way work has been distributed. Because the problem P has come, we have written that is very complex problem can be divided into 4 parts. Let's say 4 parts. P can be divided into P1, P2, P3, P4 subproblem. And P1 can be solved a user 1. P2 by user 2. We have distributed accordingly. So sometimes P3 and P4 can be able to solve only one person. That is an issue. P1 can also be able to solve P2 also. That is some other issue, right? So such a way it is divided. Then individually user 1 has solved the problem P1. Then we take a solution of problem P1. Solution for the problem P1. And user 2 give a solution for the problem P2. User 3 produce solution for the problem 3 and solution for the problem 4. There are 4 individual solutions, but what is the final result I am expecting? I am expecting that what is the solution for this P? That is nothing but solution for the problem P. Then we need to combine all the solutions, and then announce that. So you should not say that solution 1 should not reveal the solution 1 individual, should not display this result. You have to release your solution as one unique solution, that is S of P. That is possible with the combining of all the sub solutions. say this is called divide and conquer. Means that your problem is a very complex problem you have created, not simple problem. As and when user is feeling that complex problem, can have a provision to divide it into sub problems as like P1, P2, P3, and so on. Sub problems can be solved individually, user one, user two, user three. And individual solutions can be combined together, you get a final solution. This first part is divided and next solve concurrently, repeatedly solve it, then merge all the solutions. Merge all the solutions. There are three steps required again, divided problem statement. So how to write an algorithm? While writing procedure and algorithm for the problem P, so we have to follow, we are identified, this is very complex problem. Then there is a method available, the divide and conquer approach we need to follow. The divide and conquer approach says that whenever you feel a very complex problem, there is a provision that you can divide it to sub problems, solve it individually, combine as one thing as a solution. So that upfront we have to follow this divide and conquer problem. So that's what it is, starting and searching. Starting learning, the list of 10 elements. We need to sort in ascending or descending order. Then first it is divided into by sort variation. Divided into 2 halves. 10 elements can be divided into 5 into 5. Again, that 5 elements also very complex. Divide 2 halves, 2 and 3. Right? These 2 elements again get into in order. And the 3 elements are there. Again, it's 2 parts. So the divide and conquer method, we have to divide the problem into each subset will have at least 2 units. There was 2 units and one started. And 3 elements we have to again divide to 1 unit to 1 element and 2 more units are other area. 2 elements are other unit. Right. So divide by this sort of thing. This sort also okay. Right. Binary search. Binary there is a list of elements are there. Last में comment. First of all, what are the searching techniques? Last time I check up. Ayuri. Searching techniques, whatever you remember. Let me know. Sorting techniques. मैं जब भी लेके पढ़. What are the searching techniques? One minute. Searching techniques. Anyone? Why is that? Why is that? Sorry, techniques. Hello. So there are different kinds of sorting. This searching and sorting techniques. In the binary search, how are you going to follow binary search? Where the pages of there are this two different sources. I don't know where is the what element X, where is there the element? First position, right? So then what is the position? The list of array can be identified as a mid position. Identify was mid position. So to the left and to the right, compare the required element to the right. If it is less than, it may be definitely should be there in the left. If it is greater than the mid element, definitely it will be the second part. Essentially, we have to divide again X summary. Left side again is the elements. Still it is complex, again divide. Again 2 minutes, still it is complex divide. That's the value of divided into sub. So that is divided concept. Then there is a problem. There is a root map is it. The problem is that you have travel from Pakistan to Pakistan. From Pakistan to Hyderabad, for example. You want to travel from Hyderabad, Patna to Hyderabad. First of all, we check which is the shortest route is the shortest distance. Right? So, my problem statement is identify route from Patna to Hyderabad. Short distance. Okay, yeah. The problem statement is that to identify the route which is very short from Patna to Hyderabad. Is a divide and conquer is applied. Apply yes, divide and conquer. Divide and conquer apply. Problem B, what is the problem? How can we divide this problem? No, we cannot be applied this divide and conquer thing. For such a problem, this procedure will not be worked out. Then there is some other approach. Such a way for different kind of problems, different type, different procedure, different techniques are available. One of the solutions, one of the techniques is divide and conquer, and divide and conquer technique is one approach, and one method is greedy method is a one procedure, one style of solving a solution for the kind of problems which are not able to solve that divide and conquer. And which are not able to solve greedy method, we have in a dynamic programming one more approach. Few types of problems can be followed this dynamic programming. This dynamic programming. And along this 1, 2, 3 also not able to solve. The problem is not applied for these three techniques. We'll have a technique called as backtracking. Right? Branch and bone. So these are the different kind of procedure to write an algorithm. Different ways you can write solution. So always don't keep in that a problem. Otherwise, it is a very complex problem, and don't feel that which is can be applicable only divide and conquer. So some problems cannot be possible to apply divide and conquer. Now we going to discuss this divide and conquer approach. In the divide and conquer approach, before writing this, keep writing divide and conquer approach. Make a note under this. Right. The divide and conquer technique involves solving a particular problem. Everybody should note down in your notebook. Divide and this notes is enough for your internal and external. If you follow my notes one by one, definitely it will be enough. Divide and conquer technique involves solving a particular computational problem. Involves solving a particular computational problem. Solving a particular computational problem. Computational problem by dividing into complete computational problem by dividing it into, don't make noise, last one, by dividing it into one or more subproblems, dividing into one or more subproblems, one or more subproblems of smaller size. One or more sub-problems of smaller size. Smaller size. Recursively solving each problem. Recursively solving each problem recursively solving each problem, merging the solution and merging the solution to subproblems, merging the solution to the subproblems to produce a solution to the merging the solution to the subproblems to produce a solution to the original problem. To produce a solution to the original problem. Deciding divide. That first we will do divide. Side editing divide. This divide the given problem into a number of subproblems. Divide the given problem into a number of subproblems. Divide the what a little bit of class now. Then earphone happy పెట్టుకొని బయట ఎక్కడో పార్క్లో కూర్చున్నట్టు క్లాస్కి వచ్చి divide the problem into a number of subproblems. Into number of subproblems. So next heading conquer. 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 Conquer the subproblems by solving them recursively. Conquer the solving. Conquer the subproblems by solving the recursively. By solving them recursively. Recursively. If the subproblem sizes are small enough. If the subproblem sizes are small enough, however, just solve the subproblems. In straight. However, just solve the subproblems in straightforward manner. In straightforward manner. Next setting, combine it. Combine or you can say merge. Combine the solutions to the subproblems. Combine the solutions to the subproblems. Solutions to the subproblems into the solution for the original problem. Into the solution for the original problem. Next heading, general method. Next heading, general method. Sometimes in the recurrence part of it, explain control abstraction method for divided conquer. Was also see control abstraction method for divided conquer. For divided conquer. Can see. What is general algorithm for the whole technique? So algorithm. While writing an algorithm, the rule is that first write the algorithm followed by algorithm name. Write the word algorithm followed by algorithm name. This algorithm I am going to write for the divide and conquer. No, you can say DAC of divide and conquer method for the problem B. Right? So first what will do? I'll check to find a solution for the problem B by using divide and conquer. Before that, applying divide and conquer approach and check whether the problem P, is small. Problem P is small problem or complex problem. If problem P is small, no, it is not a complex problem, then the problem P is very problem or small problem. Then no need to divide into some problems. Then simply produce. Okay, right? Then produce solution of P. Direct solution you can solve. Else means this. The problem P is not a small problem. The problem P is not a small problem. Then divide. Then divide P into smaller instances. That is P1, P2, P3, and so on. Pn. And apply. So what happens here? The problem P is you identified not a simple problem, then it is divided into subproblems. Once it is divided into subproblems also, again you check it out whether this P1 is simple problem or not. If still it is feeling that P1 is not a simple, I am unable to solve by alone as P1, then I can divide it into P1 and P1 2, P1 3 as my subproblem. Means that once it is applied divided conquer method for the original problem, I have divided into number of subproblems, and that subproblem also you have to apply again divided conquer. Again you have to check whether subproblem are divided. Means this is there are 10 elements. I want to search an element for X. First of all, I have divided it into two parts by finding a mid position. So, mid position is 5. First part and second part. First part contains again 5 elements, second part 5 elements. So, still I feel that 5 elements also not able to search for my element. So, if it is only one element, 5 elements is easy. Then what I have to do for subproblem also again I check whether it is simple or not. Further, please apply this BMC method for P1, P2, P3, P4 also. Once it is applied at P1, P2 for DSC, as and when you feel it is simple problem, it is not simple problem, divide it. If you feel the P2 is applied divided on case, it is simple itself. You assign to directly find a solution for the problem P2. Right? Then apply DSC method for apply divide for these subproblems. For these subproblems. For these subproblems, only apply divide. If it is small, direct solution. Otherwise, only divide. Then finally it returns. Right. Next time. What happens here? It is actually we are applying DAC of P1, DAC of P2. So on DAC of N. One is but they are divided on last step combine here. So return by combining all these. This DAC of P1 it gives a solution, direct solution, problem P1 simple. If P1 itself complex problem is money divide is. Our divide is like money divided in conquer applies. So P2 is a small problem, here itself we get a solution. So all these solutions will be combined as a one solution. Algorithm will be closed. is general algorithm for the divide and conquer approach, not for searching algorithm, sorting algorithm. So divide and conquer lo procedure ఏం చేయాలి అంటే whenever you identify your problem, ఆ ప్రాబ్లమ్ కి డివైడ్ అండ్ కాంకర్ అప్రోచ్ అప్లై చేయించాలి అని ఐడెంటిఫై బై అబ్జర్వింగ్ దిస్ స్టెప్స్. ఈ స్టెప్స్ ఏంటి? ఎప్పుడైతే ప్రాబ్లమ్ ఇస్ కాంప్లెక్స్ ప్రాబ్లమ్ దానికి డివైడ్ అండ్ కాంకర్ అప్లై చేయి అండ్ డివైడ్ ఇంటూ స్మాలర్ ప్రాబ్లమ్స్, మళ్ళీ డివైడ్ చేసి still you are feeling for the divide. So you have to analyze the problem that whether it is possible to divide it into number of. If it is so, divide it and assign individual sub-problem tasks to individual users. Then ask them to solve individually. Once they have given a solution, all the solutions and announce that this is part of this. Okay. But you have to get an idea that this is a problem under this divided concept. That is analysis. Right? Then next term, applications of divide and conquer. Applications of divide and conquer. Sir, before going to so here before going to discuss applications, I wanted to say here one how to check whether your solution is provided now. How to check the solution is correct or not. So that will be measured by performance. Right? So before going to discuss the applications, we have analyzed an algorithm or it is designed. So algorithm for the problem P1. So I have to analyze this. So how to analyze that? We have a recurrence relation. We class to different recurrence relation for divide and conquer methods. What is the recurrence relation? T of n is equals to 1 if problem happens into problem n equals to 1. Otherwise, there is a into P of n by d plus CR some constant or n. Maybe n. And then a recurrence relation. అది ఆల్రెడీ క్లాస్ లో అయిపోయినట్టుంది, మళ్ళీ చెప్పాల్సిన అవసరం లేదు. ఉందా రికరెన్స్ రిలేషన్? So there is a recurrence relation. A into P of n by d plus f of n. This f of n. So the recurrence relation is what divide and conquer loss. Conquer the solution for recursively. At the same solution name, same formula, repeated apply, then you get a solution. Right? So for that here I can define time complex revision. Time complexity measured T of n is equals to 1. అంటే ఈ ప్రాబ్లం ని సాల్వ్ చేయడానికి 1 unit of time is enough. When the problem will have only one input, it is equal to 1 input. If more than one input, that is called, you can say, complex problem. For that, the recurrence relation is a values of P can be divided into P by 2. P by 2, P by 2. So P by 2 also complex according. Only again P by 2 by 2. That is P by 4. And it is also P by 4. P by 2 still complex. Only 7. Only 7. Only half. So that's what the sub constant A is the one constant value. Time required to divide into a sub problem. So total energy divide and conquer method. It is not dividing directly 1 unit of time. If it is divided, so total solve we need to consider the problem can be divided possible, but also time will be considered. After this, we need to solve individually solve here, right? Divide and also solve. For solving of each problem, we will take some amount of time. That also can be added. After solving, we need to combine all the sub-solutions. For that combining also we take some amount of. All these times can be measured. So here, K of n by 2 can be n by b. Will be time required. Time required to divide the problem into sub-problems and solving. This f of n is the time required to combine. Right? So one line right down. The recurrence, the complexity of divide and conquer. The complexity of divide and conquer. The complexity of divide and conquer VAC. Algorithm VAC algorithm is given by recurrences of the form is given by recurrences of the form E of n is equals to 1 and A into E of n by b less f of n equals to 1. And this equation when n greater than write down this equation where a comma b where a comma b are known constants. A comma b are the known constants and t of 1 is known value. T of 1 is known value and f of n and n is the power of b and this is important. N is the power of b. N is the power of b. That is n is equals to b power t. N equals to b power t. Noted. If it is noted, this continuation. Consider one example. Consider the case in which a equals to b equals to 2. Consider the case in which a equals to 2 and b equals to 2. Let t of 1 is equals to 2. Let t of 1 is equals to 2. T of 1 equals to 2 and f of n is equals to n. F of n is equals to n. F of n is equals to n. So substitute in this. T of n is equals to a into T of n by b plus f of n. What is a value? Substitute a comma b comma value and f of n by 2 into T of n by 2 plus n. Right? Let's say this is equation 1. And what is T of n by 2? We don't know T of n by 2. To where that? Substitute, note this. Substitute equals to n by 2 in equation 1. Then T of n equals. Equation 1 is T of n equals. Wherever it is n, substitute n equals is by 2. Then 2 into T of by 2 by 2. Plus 2 into T of n by 4 plus N by 2, this is equal. 5 minutes break. Which is the break? Well, health care money break is same. 11 is already 11. We can go 1 o'clock. Right? Today we'll talk. Today we'll take 1 o'clock. It will be there now till 2 o'clock. Best time will start at 12 o'clock. No issue. We go 1 o'clock, it will be there now. 4.
మొత్తం తెలిసే KIEW చేస్తుంది.
Compulsory break, మనకు problem not break.
ప్రాబ్లం కాబట్టి 11 10 ఉండాలి.